Good evening, my dear friends. Today I will take the new topic about the deflection of the beam along with the bucking of column. So I would like to recall the previous units like torsion along with the shaft. I would like to recall the parameters which we have studied in the last class. So that topics our friends to be discussed with you all. Please listen it.
Good afternoon, everyone. My name is Darian. I am now going to speak about the differences between the solid shaft and the hollow shaft. The main difference between the solid shaft and the hollow shaft is the circular cross section. The solid shaft has the same symmetrical, fully loaded circular shaft, while the hollow shaft has a circular cross section with two diameters, the inner diameter and the outer diameter. What change it creates is the heat dissipation and the power transmission. Since the solid shaft has much lesser weight, it can transmit more power, hence it is more efficient. But a solid shaft can transfer only less power. The solid shaft has all the material inside its cross section, so the heat dissipation becomes the main problem. So the hollow shaft can dissipate more heat at a better rate than the solid shaft. The next is the weight. Automatically we can know that the solid shaft is of less weight. So less weight means the hollow shaft can run at a higher speed than the solid shaft, which creates the edge between the solid shaft and the hollow shaft. The solid shaft is very easy. The solid shaft is very easy and much cheaper to production than the hollow shaft. Thank you.
Hi, this is Srimadhi. Now I like to share about the topic of spring. The spring is a mechanical component that stores energy. When it is subject to a force. It releases energy when the force is removed. It is used in shock absorption and contact between the two surfaces, and it works on the motion control system in mechanical machines. In simple terms, spring stretches, twists or compresses. It stores energy and return to its original shape. There are two types of spring mostly used in mechanical system. The one is helical spring and another one is a leaf spring. Helical spring. Helical spring is nothing but it is made up of made by a wire into a helix shape, which is known as a helix spring. There are three types of helical spring: compression spring, extension spring, and torsion spring. Compression spring works under compression force when it loaded. Extension spring when it works under tensile force, and torsion spring it works under the twisting force, stress energy by twisting. And another one is the leaf spring. Leaf spring consists of several plates of material which stacked together and act as a weight gaining material which is used in suspension of heavy load vehicles. Thank you.
Hi, myself Ratnamurthy. Today I would like to talk about the topic of stresses in springs. Stress is the internal force acting on a material when the load is applied. The stress is calculated by force by area. When the stress exceeds the limit, it may fail or break. When a load is applied, the spring occurs and the internal stress are produced. In a helical spring, the main stress is shear stress due to twisting of the wire. There is also shear stress due to the applied load. So the total stress is the combination of both. The amount of stress depends on the load, wire diameter, and a coil size. To get accurate results, we use a correction factor called the wall factor. In leaf spring, the stress is mainly bending stress, while in torsion springs it is a torsion stress. The stress is too high, the spring may fail more due to fatigue or overloading. Springs are widely used in vehicles, machines, and shock absorbers to absorb energy and reduce vibrations. Thank you.
Hi, myself Harrison. Here I am going to speak about deflection of beam. The deflection of beam is the bending moment or displacement that occurs when the load is acting on it. When a force like a point load or UDL distributed load got a beam, it tends to curve from its original straight position. The amount of deflection depends on the factors such as the magnitude of the load, the length of the beam, the material properties. Here's the example for this. In a simply supported beam with the control with the center point load, the maximum deflection occurs in the center of the beam. In cantilever beam, it occurs at the free end. Understanding deflection is very important in engineering design because it ensures that position of the structure or within correct structure which have ensure the safeties. Thank you.
Now I am going to tell you about torsion formula. In strength of materials, the torsion formula, also known as the torsion equation, describes the relation between the applied torque and the initial shear stress and the angular deformation of a circular shaft. It is a fundamental equation used to design drive shafts, axles and other rotating components. The formula for torsion is T by J is equal to tau by R is equal to G theta divided by L. The T is applied for torque for twisting moment. The J is the polar moment of inertia, and tau is the shear stress of a distance. R is the radial distance from the central axis. G is the modulus rigidity.
So in the other form, we can calculating the torque, which means we are getting the power along with the RPM means power is equal to 2 pi divided by 60. Or else we are known the director of hollow shaft, solid shaft. The formula becomes T is equal to pi by 16 into tau into d cube. So this relationship we can able to calculating the total torque. After go with the respective of either breadth or dia or shear stress or maximum slope, whatever we need, we can calculate in this kind of formula. So torsion equations generally T by J is equal to tau by R is equal to C theta divided by L. In the problematic, in case the shear stress value is not directly given, means we can go with the T by J is equal to C theta divided by L. So this combination will enhance in the unknown parameters. So these are all the topics which can be studied with the torsion and the beam. Thank you.